Okay, hello and welcome to another past paper recording. Today's past paper is an S1 exam. This is November 2023, variant 5.2. Let's begin. It says the competitor is throwing. We just first open up the marking scheme as well so that we're not lost. Okay. The competitor is throwing a event has 3 attempts to throw a ball as far as possible. The random variable x denotes the number of throws that exceed 30 meters. The probability distribution table for x is shown below. Given that expectation is 1.1, find the value of p and the value of r. So the first thing that I know about this question is that if I add all of them up, it should give me 1. So p plus r is 1 minus zero point 0.4 minus 0.15, which is, I think, 0.45. And for the expectation, you do x into px and you sum up everything. That's 1.1 p plus 2r plus 0.45. Okay, that should be giving me 0.65. You can do an elimination. It's to 0.2. Okay, find the numerical value of variance of x. So variance of x is x square px sum minus mean square. So 0 square into 0.4 plus 1 square into 0.25 plus 2 square into 0.2 plus 3 square into 0.15 minus 1.1 squared. Okay, that should give me 1.19. Moving on to the next question, it says it has a five-sided spinner with side labels 1, 2, 3, 4, 5. He spins the spinner and notes the number on the sides on which the spinner lands. Find the probability that it takes fewer than 7 spins for George to obtain a 5. Okay, so fewer than 7 spins. I'm not giving you n in this case. I am just treating this as a geometric. Whenever you get the first success, you stop. So I'm asking you to calculate the probability of x probability of x less than 7 in a geometric situation. Okay, what is the probability of getting a 5? It's 1 out of 5. So I'm going to say that my probability of success is 0.2. Probability of x less than 7 doesn't have a has the formula 1 minus q power r minus 1. So 1 minus zero point 0.8 power 6. That gives me 0.738. George spins the spinner 10 times. I am telling you what the number of spins is. Find the probability that he obtains a 5 more than 4 times but fewer than 8 times. So probability of 5, probability of 6 plus probability of 7. Then C5, zero point 0.8 power 5, zero point 0.2 power 5, and C6, 0.8 power 4, zero point 0.2 power 6, and C7, 0.8 power 3, 0.2 power 7. Okay, let's just use 5, 6, 10 point 0.0264. 5.505 into 10 power minus 3. Okay. 0.0264 plus 5.505 into 10 power minus 3. Point minus 30 greater than 1.881. Okay, continuing with question number 3. Factory produces a certain type of electrical component. It is known that 15% of the components produce a faulty. A random sample of 200 components is chosen. So 200 components is chosen and P is 0.15. Use an approximation, so if this is binomial to normal, there is no other way of doing it, that more than 40 of these components. So probability of X greater than 40. Let's first do a continuity correction and say that this is becomes 40.5. So I get NP, which is my mean, as 200 into 0.15, which is 30, and sigma square as NPQ, which is 200 into 0.15 into 0.85, which is 25.5. Okay. So given that I have this, I will say that probability of Z greater than 40.5 minus 30 divided by root of 25.5 gives me what? Let's check on our calculators. 40.5 minus 30 divided by root of 25.5. That gives me 2.079. Let me check if that is the correct number from the marking scheme. Yes, that is the correct number. So I get Z is greater than 2.079. So 1 minus 5 of 2.079, because this is greater than, let's check from our table. 2.079, 079, 9812, I think. Okay, if that is correct, yes. So I get a final answer 0188. Moving on to the next question, question number 4. The heights in centimeters of the aces and jets are shown. Draw back-to-back stem and leaf diagram with aces on the left-hand side. So I need aces on the left-hand side. And jets. Okay. I see that the stems have to be 16, 17, 18, and 19. Let's first do the aces. Let's start with 6. So I see 6, 8, I see 4, 6, 8, and 9. Okay. And then 1, 3, and 4. Then 1, 0, 1, 2, 2. For the jets, it's 6 and 8. Then 0, 4, 4, 5. And then 1, 8. Just for correct. I'm saying the players and the aces. So half n plus 1 th will give me the median. So I'm looking for the sixth value. Let's look for the sixth value. 1, 2, 3, 4, 6. So 73 median. And fourth, what is the value? 8, slower quartile, 3, 9, 7, 8, 181. Upper quartile. Interquartile is 181 minus 168. That should be 13. if I am correct. Yes, I am correct. Give one comment comparing the spreads of the heights with the spread of the jets, aces with the jets. Now, I don't have the interquartile range. I can calculate that quickly. If I want, I can just say that this is, I'll again have third and ninth value. So 1, 2, 3, 170 is the third value. 4, 5, 6, 7, 8, 9, and then 188. So 188 minus 170 will give me a bigger interquartile range. So the heights for jets are more spread out than heights for aces. Okay. Okay. The height of the members of a club are normally distributed with mean 66, 166, and standard deviation 10. Okay. Find the probability that a randomly chosen member of the club has less than 170. This looks like a very simple question. 0.4. That's 0.6554. Yep. Round off to three significant figures. Given that 40% of the members have heights greater than h, find the value of h. So this is a bit reverse reading. Simple question again. So 1 minus phi of h minus 166 over 10. Phi inverse. What's phi inverse of 0.6? You go inside the table and now you start looking for 0.6. So I see 5987. I need another 13. I don't have another 13. Let's go with 12. So I get 0.2, 5, and 3. 0.2, 5, and 3. Okay, so that's 25.3, 2.53 plus 166 equals to 168.53. Round up to three significant figures. So I think 169. I'm not sure if rounding off to three significant figures is what I want here. Does it say something? It says two decimal places. I should keep two decimal places. Then the random variable x is normally distributed with mean mu and standard deviation 2 over 3 mu. Find the probability that the randomly chosen value of x is positive. Positive means greater than 0. Okay, so I get minus mu divided by 2 over 3 mu. Mu cancels out. 1 divided by 2 over 3 will give me minus 3 over 2. Okay, so that becomes 1 minus 5 minus 1.5. 1 minus, how do you change the minus? You again do 1 minus. So this becomes 5 1.5 eventually. 0.9332. Okay, let's check if that is the right answer. Yeah, that is the correct answer. Round off to three significant figures. Okay, then okay, continuing with question number six. Freddy has two bags of marbles. Bag X contains seven and seven blue. So bag Y contains this. Freddy chooses one of the bags at random. Some marble is removed at random from the bag and not replaced. So first he's choosing the bags. So let's just write down X and Y, half and half. Okay. Second marble is then removed. New red marble is now added to each bag. So once he removes the first marble, he adds a red marble. So I'm going to say that the first has two branches, red and white. Let's first make that. Okay, 7 out of 10 and 3 out of 10. 4 out of 5 and 1 out of 5. Then a red marble is added and the second one is then removed. So what I have here now is that although there were seven red marbles and I picked out one, and because I added another one, this remains the same. And what happens to the white ones? They also remain the same. But when I have this, for example, now I've removed a white one. So the white ones are 2, but the total is 10. Why? Because I added another one. So this is 8 out of 10. Okay. Number second, and the same bag and the first marble has been removed. Okay. Then I have red and white and red and white. Okay. So red again remains the same, 4 out of 5 and 1 out of 5. Why? Because I added another marble. This becomes 0 out of 5 and 5 out of 5. So this branch is technically absent and I shouldn't be drawing it just to reduce the number of outcomes that are there. Okay, showing the probability of each of the branches. So I have all of that. I have shown you all the branches. Let's move on. Find the probability that both marbles removed from the bag are the same color. So I should have XRR, XWW, YRR. There can't be YWW. Okay. So what's XRR? It's half into 7 over 10 into 7 over 10. That gives me 49 over 200. XWW is half into 3 over 10 into 2 over 10. That gives me 6 over 200. And half into 4 over 5 into 4 over 5. That gives me 16 over 50. So 49 over 200. I should do that working here, but since it's on the other page, I'm just writing these down here for you. Okay, let's see if we get the correct answers. I am getting 119 over 200. Okay. Okay, moving on to the next question now. It says find the probability that bag Y is chosen given that the marbles removed are not both the same color. Bag Y given not same. So not same will come up in the denominator. Now in the previous part you've calculated same, so you could just do 1 minus 119 over 200. That was the number. Yeah. 119 over 200, not 119 200. Okay, 119 over 200, and I'm talking about this branch, this branch, this branch, and this branch. Okay, let's see where we have different colors. We have XRW. We have, I don't need actually all these XRWs. I just need the ones with Y. So it's going to be YRW and YWR. So it's going to be half into 4 over 5 into 1 over 5. Half into 4 over 5 into 1 over 5 plus half into 1 over 5 into 5 over 5. Okay, let's see if we get the correct answers. 4 over 50 plus 5 over 50. Okay, divided by It's a long calculation. Yep, I'm getting 4 over 9. That should be the final answer, so 4 over 9. Okay, so bag Y given not same is YRR, YRW, and YWR. And the not same is simple. Okay, then question number 7 says find the number of different arrangements of the 9 letters of the word Andromeda in which no consonant is next to another consonant. Okay, so let's write Andromeda. Okay. In which no consonant is next to another consonant, the letters D, M, N, and are consonants. So what I am going to do is I'm going to first arrange the vowels. One, two, three, four vowels. And there are five consonants. Okay, so the vowels could come up here and be 4 factorial divided by 2 factorial. Okay, then the consonants can only be in these 5 places. So it's simply going to be 5 factorial divided by 2 factorial. I hope that will give me the correct answer. 720 is my final answer. Okay, let's check if that is correct. Okay, part B, find the number of different arrangements of the 9 letters in the word Andromeda in which there is an A at end, each end and the D's are not together. So 1, 2, 3, 4, 5, 6, 7, and 8 and 9. Okay, so the A's are there, the rest of the letters are there, so that's 5 factorial. Then the D's could come up here. How many places? 1, 2, 3, 4, 5, 6. So 6C2 into 2 factorial, arranging the D's and then dividing by the D's and not dividing by the A's. Why? Because that is already there. They're already fixed. You don't need to divide them. So you get 1800 and that's just your correct answer. Okay. 4 letters of the word Andromeda from the 9 letters are selected. Find the probability. Now you have to do double counting. Remember that you first fix the denominator. So denominator is 9C4. Okay. At least 1D and exactly 1A. Okay. At least 1D and exactly 1A. So I could get D, A, and 2 others. I could get 2Ds, 1A, and 1 other. So I'm going to first select the D's, 2C1, I'm going to select the A's, and then from the remaining letters, 5C2. Then 2C2, 2C1, and then 5C1. Let's see what we get. Get 40 from here, and I get 10 from here. So that gives me 50. 9C4 gives me what? 126. So I get 50 divided by 126. I hope that's the correct answer.